All right, so now that we know how to form some organohalides, let's take a look at some of their reactions. So first off, we're going to take a look at the substitution of these guys, right? So we have some kind of organohalide, we have some kind of nucleophile, and we substitute them out, right? So now our nucleophile is attached to our carbon skeleton. And so if you think about the process, there's two main ways you could do this. In this first way, you have this nucleophile attack this carbon, and then the halogen leaves all in one step. Right, so we see that this is a one-step reaction. The nucleophile forms the bond with a carbon. At the same time, the carbon halide bond breaks. The other way to think about this is first, this halogen leaves. You're left with a carbocation. And then the nucleophile attacks the carbocation to give you your product. As you can see, we've got the same end result, but we've taken different routes to get there. And this is important because this is going to influence your reaction under certain conditions, right? So this top one up here, that's one step. We call this SN2. It's one step, but it's called SN2. This one down here, that's two steps, we call SN1. So it's a little bit confusing. The SN2 is one step, while the SN1 is two steps. SN2 is one step, SN1 is two steps. The more confusing way. And so we're going to take a look at SN2 first. As we said, it's one step. So these things are occurring at the same time, right? First, we have this nucleophilic attack. So we're forming this nucleophile carbon bond, and at the same time, we're breaking this carbon halogen bond or carbon leaving group bond, and we're having a leaving group leave. To end up with our product. And so why do they call it SN2 if it's one step? And that's because this step is bimolecular. In order for this reaction to occur, these molecules must slam into each other, right? So if we think about the kinetics of this, we can write the rate law. The rate law is going to be equal to K times the concentration of your nucleophile times the concentration of whatever your substrate is, right? And so it's bimolecular. So SN2, the S stands for substitution because that's what we're doing. The N stands for nucleophilic because we have a nucleophile attacking. And then the 2 stands for bimolecular. And again, this is one step. So a little tricky, but you got to keep it straight.